Okay, today I'm going to start in my mind would be the second half of Algebra 1. All year long so far, we have been dealing with either getting ready for linear equations or doing things with linear equations. And remember, what linear equations are basically a real simple way of saying dealing with straight lines. So, if I have a graph that's a straight line, that's a linear equation. And all year, that's all we've been doing, is dealing with linear equations. Today, we're going to start laying the foundation for a new type of equation called a quadratic equation. So all the stuff that I'm about to start teaching you in this chapter and the next two chapters are all going to deal with quadratic equations, which is a fancy word for a U-shaped line or a curved line. All right, you're going to spend most of your higher level mathematics dealing with curved lines. Most things in complicated mathematics don't deal with straight lines, but they deal with curved lines. For example, satellites in space, shooting a rocket to its space, figuring out the launch velocity of a kitten. All those things deal with curved lines, not straight lines. When you throw a rocket in the air, it doesn't go in a straight line, it goes in a curved line. When you throw a kitten in the air, same thing. So keep that in mind. We're dealing with curved lines from now on, so everything is going to be building towards being able to do that. Okay? And just like when we did linear equations, we had to go to some basic rules. Today, we're going to start dealing with the basic rules of curved lines, which deal with squaring and cubing and things of that sort. So that's what we're going to do today. We're going to learn how to multiply numbers with exponents. Now, when I first taught, I did this lesson very different than the way I do it today. I used to teach some rules, and there are some rules that you could just look up in lots of different places of how to multiply exponents using rules, okay? In fact, if you can see in my notes here, it says simplify using the power rules, because these notes actually used to have rules to them. But now I just say, this is the way I want you to start doing it. Expand the exponents and simplify. Now, what does that mean? All right, what does 7 to the third mean? Well, if you thought about it for just a second, I think you already know this. It does not mean 7 times 3. It means 7 times 7 times 7, right? That's 7 to the third, right? Basically, there's 3 of those. And 7 to the fifth is 7 times 7 times 7 times 7 times 7. Basically, there are 5 of those. Okay? So if I wanted to simplify this, and we don't have to multiply it out because that's a massively huge number. But if I wanted to simplify this into writing this as small as possible without actually doing the math, what I would do is figure out, well, how many 7s do I have? 1, 2, 3, and then 5 more is 7 to the 8th. Now, there are some rules, and you could look them up. But as you go along, you're going to start realizing what the rules are on your own. Okay? So all I want you to do from now on in this entire chapter is to expand. Sorry, I lost control of my pen for a minute. So what I want you to do from now on is just to expand them out. As you get good at this expanding, you're going to start realizing that there are rules and they're pretty common sense. Okay? And I'm not going to show you the rules right now. All right, example 2. 5 times 5 to the fourth. Now the first thing I want you to do is realize that means 5 to the first, right? So if I was to expand this out, I have 5 times, that's the 5 to the first, and then I'd have 4 more 5s. 1, 2, 3, 4, right? Which becomes, I know this seems simple, but it becomes 5 to the fifth. Okay? Easy enough? What some people do is they'll actually multiply these powers. So 3 times 5, because I'm multiplying, so I multiply 3 times 5 is 15, which is saying that you have 15 sevens, and that's wrong. The same thing here. 5 times 5 to the fourth is not 1 times 4. You're actually adding them, right? You're adding the powers. All right. Example 3. Same thing again. The first thing I want to talk about is this negative number in a parentheses. Okay? If you have an Inspire calculator in your hand right now, and you type this, -2 squared, and then you typed -2 in parentheses squared, you would actually not get the same answer. I don't have an Inspire with me right now, but if you type this into a calculator, -2 squared, you will actually get -4. If you typed in -2 in parentheses squared, you would actually get +4. So the question is, what the heck is happening here? You would think -2 squared is +4 because a negative times a negative is a positive. But if you don't put the parentheses, your calculator, when it sees -2 squared, what it is seeing, it sees this negative as multiplication. You're multiplying the 2 by a -1. So what your calculator sees is it sees an exponent, and it sees a negative, which means multiplication. That makes sense? And you're like, well, a negative doesn't really mean multiplication. Another way of thinking what a negative number is, it's a positive number times -1. So what your calculator sees, it sees exponents and it sees multiplication. And then the question is, using PEMDAS, what is it going to do first? Well, it's going to square first. So what your calculator is going to do is it's going to do 2 squared, which is 4, and then it's going to multiply it by a -1, which makes it -4. Now, if I do it this way, what happens? Well, since the -2 is in a parentheses, then it's going to do the math for the multiplication first, and then it's going to square second, which will give me the +4. So what I'm saying that for is keep numbers in parentheses. My rule for you all is when in doubt, include the parentheses. And that's what we're going to do here. -7 to the third means -7 times -7. Keep the parentheses times -7, right? Real simple. -7 to the sixth means -7 times -7 times -7. It's already getting annoying writing it, but you'll get over it. -7, -7, -7, right? What is this? This is the 3, right? And this is the 6 -7s, right? So if I have 3 -7s and then I have 6 more -7s, how many -7s do I have? Well, I have -7 to the 9th. Okay? Make sure you include that parentheses. Now, some of you all may be thinking, well, the parentheses don't make a difference here because both ways it's going to be negative, but we're not going to get into that right now. Include parentheses if you're not sure. Okay? Next example, example 4. Just like before, put the 1 there for the power. So I end up with x, that's my x to the first, times 4 more x's, 2, 3, 4, times 3 more x's, 1, 2, 3. Well, that's easy. How many x's do I have? 1, 2, 3, 4, 5, 6, 7, 8. X to the 8th. Easy. All right, next example. 4 squared to the 7th. In this problem, what I want you to do is recognize that 4 squared to the 7th means you have 4 squared 7 times. You know what, let's make our lives easier. Let's make this 4, just to make our lives easier. So that's enough, right? I don't want to write 7 of those, and neither do you. 4 squared to the 4th means how many 4 squareds do I have? 4 of them. 1, 2, 3, 4. Now from here, what you could do, you have 2 options. You can visualize what 4 squared is because 4 squared times 4 squared is 4 times 4. So how many 4 times 4 do I have? Well, there's 2 there, there's 2 more there, there's 2 more there, there's 2 more there. That would be 2, 4, 6, 8. I have 4 to the 8th power. Make sense? If that does not make sense to you, then all you have to do is right here, 4 squared is really 4 times 4. That's 4 times 4. That's 4 times 4. And that is 4 times 4. So you have 8 4s, which is 4 to the 8th power. Got it? All right, next example. I have x to the 5th times 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 x to the 5th. Why do I have that? Okay, here's the deal. I have 5 groups of this. So 1, 2, 3, 4, 5 represents the power of 5 there. I hope that makes sense to you. So what is this basically saying? I have 5 groups of x to the 5th. 1, 2, 3, 4, 5 that I'm multiplying, right? Now, if you need to, you could multiply them out. You could say that, well, that's x, 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 x. And that'd be, every one of those would be that. So how many x's do I have? Well, 5, 10, 15, 20, 25. X to the 25th. Okay? Next example. 5 to the 3rd to the 4th power. Well, that would mean how many 5 to the 3rds do I have? 4 of them. So I have 5 to the 3rd times 5 to the 3rd times 5 to the 3rd times 5 to the 3rd. Which by now I think you're already getting the point. It's real simple, right? 5 to the 3rd times 5 to the 3rd times 5 to the 3rd is 5 to the 3, 6, 9, 12. I have 3 5s there, I have 3 5s there, I have 3 5s there, I have 3 5s there. That's 12 5s. Got it? Okay, next problem right here. Now, this problem kids mess up on all the time. In fact, I'm going to star it right now because people mess this problem up more than anything else. Here's the first thing I want you to understand. Go ahead and put your pencil down for a few minutes and just watch this, okay? If I had 2 plus 1 squared, right? This is what people think you do. Well, they think you can take this squaring and use it like a distributive property. They think that you can square the 2 and square the 1. So they think it's the same as 2 squared plus 1 squared. Let's just do the math real quick. Let's see if that's true. What's 2 plus 1? 3. 3 squared is 9. The question is, if this works, then this should equal 9. And does it? Well, 2 squared is 4, plus 1 is 5. You see, you cannot distribute the exponent. You cannot take this square and distribute it, okay? I wish you could. If you could actually do that, higher level math would be a lot easier. But unfortunately, this is 100% wrong. Let me say that again. You cannot distribute powers if you have addition inside of parentheses, okay? If it was like this, then yes, you could distribute. But as soon as it becomes this, you cannot distribute, okay? That is a big, big time no-no. You don't understand it yet, why that's so important, but you cannot do that. Now, here's my question for you. Since you can't do that, then what can you do? Well, there's a lesson that we're going to do in a couple days called foiling, and this is what you could do. What you could do is this. You could recognize that 2 plus 1 squared means 2 plus 1 times 2 plus 1, right? And then what you could do is you could distribute the 1 to that and the 1 to that, and then you could distribute the 2 to that and the 2 to that, and you actually do get the right answer. Okay? That's actually what you can do, and that's called foiling, and we're going to get to it later in this chapter. But right now, the key that I want you to understand is you cannot distribute powers like you can distribute multiplication. Okay? If you want to distribute, you have to distribute like this, and we're not going to get in that today. All right, so I say that to tell you this. You can't do anything right now to the x plus 1. So when I see this, I see x minus 1 squared times x minus 1 squared times x minus 1 squared, right? Because there's 3 of them. X minus 1 squared, and I have 3 groups of them. 1, 2, 3. Got it so far? And then each one of these squares would be x minus 1, right? So this would be x minus 1 times 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 x minus 1. And that is going to be what? Now, I'm not going to require you to write all this out. If you see it like this, and I hope by now you're starting to see that, that'd be 2 x minus 1s, that'd be 2 more x minus 1s, that'd be 2 more x minus 1s. So my answer is x minus 1. How many x minus 1s do I have? 6. And remember, you cannot say, well, that's x to the 6 minus 1 to the 6. That is absolutely wrong. I wish it was right, but you cannot do that. Okay? All right. Now on to example 9. We're going to simplify this using the power rules. All right, so what does that mean? Well, that basically means simplify means to solve it with numbers if possible, okay? So that's what I'm going to do here. If I have 20, I'm going to multiply it out. I'm not going to leave the powers anymore is what I'm saying. And on your homework, when I give you these, I'll tell you which ones I want you to solve and which ones I want you to leave as powers. In this case, we're not going to leave powers if possible, okay? So on this first problem, 24 times 18 squared means 24 times 18 times 24 times 18, right? Which, if you got technical, means 24 squared times 18 squared. Because why is that true? Because I have two 24s and I have two 18s, right? 24 squared times 18 squared. All right, well, 24 squared is 576, and 18 squared is, what is that? Is 324. So then from there, I want to multiply 576 times 324. You can use a calculator for this. This assignment is not going to be about all that crazy math. So use a calculator when you get down to the math. So if I bust out with a calculator, I get 576 times 324 equals 186624. So that's how I'm going to write 186624. Now, a lot of the problems that you do tonight are not going to be that big, but tonight, in the second half of your homework, you need to multiply them out, okay? All right, next example. 7x to the third means how many 7x's do I have? Well, I have 1, 2, 3 of them, right? 7x to the third means 3 7x's, right? And 7x to the third means 7x times 7x times 7x. So what I could do is then say that's 7 times x times 7 times x times 7 times x, which means it's 7 to the third times x to the third, right? Now, do I know what 7 to the third is? Well, if you do the math real quick, it is 243 if I'm not mistaken. Check that on the calculator real quick just to make sure. 7 times 7 times 7 is, yeah, 343. Oh, I said 243, didn't I? Well, it's actually 343. So let's fix that real quick. Anybody on the math team, excuse me there. 343 times x to the third, which is, I can't multiply numbers and letters, I just got to leave them. So my answer is 343x to the third. Okay, so let me summarize what I did here, because this is the new type of problem. 7x to the third means 7x times 7x times 7x, which means 7 times x times 7 times x times 7 times x, right? Well, 7 times 7 times 7 is 7 to the third, and x times x times x is x to the third. 7 to the third is 343, and x to the third is x to the third. Bring those together, you get 343x to the third. All right, so let's see one more example. 9n squared, right? 9n squared squared. So what does that mean? Well, that means 9n squared times 9n squared, because I have two groups of 9n squared. Now, if you want to, you could change that to 9 times n times 9 times n times n, which becomes 9 squared, which is 81, and then n times n times n times n is n to the fourth. And there you have it. Not hard at all. You don't realize it yet how important this is, but we're going to be using this throughout the rest of algebra, and by the time you're done with algebra 2, this stuff should be simple to you, because you're going to be using it so often. So make sure you get it down, make sure you're expanding, and you should have a pretty easy time. Good luck.